All right, hey, so we're talking about the determinant and inverse matrices in this video. So just a nice thing to note, and it might take a little load off of you if you're worried about this stuff, is, and for this class only, you really only will be asked to compute 2 by 2 matrices for the next 2 concepts, and for solving systems of equations, which will be the next video. So the determinant, the inverse, solving systems of equations, all of these things are just going to be done with 2 by 2 matrices. So don't sweat it if you think that matrices are impossible, especially when we get to 4 by 4s and 5 by 5s. So we're just going to stick with this concept this way. So the determinant is really going to be giving us a number, and the determinant of, let's say we're dealing with matrix A, for example, is really just simply equal to these components. So it's going to be A times D minus B times C. Now, let's say that our matrix looks like this, where we have a 2 by 2 matrix, again, where it's going to be A, B, C, and D. Now, please keep in mind that this is the general notation for how we would label a matrix. Notice how it's A and B on top, not A and B down the column. So it goes A to B, and then the next row goes C, D. So if I were to give you an example of how to really compute something like this, I would say that, let's say that matrix A is equal to 6, 4, 12, and 2. So that means that the determinant of matrix A will be equal to A times D, right? So the formula stays the same no matter what we're doing. So A times D minus B times C. So 6 times 2, right, minus 4 times 12. So, pretty simple. All we have to do is compute this. So this is going to be 12 minus 48 is going to give me a negative 36. This may or may not be the best first example to show you because it's a weird big number. A lot of times you'll find determinants is smaller, especially in this class. But this is just to show you that this, in fact, is a determinant, and we can have negative numbers. Now, one interesting thing to note about the determinant, and it does relate really, really closely to the inverse concept, is that if the determinant of A is equal to 0, that means that there is no inverse matrix. And if the determinant does not equal 0, that means that there is an inverse matrix. And you might be wondering, well, what the heck are we talking about in terms of an inverse matrix? So let's say that, for example, I have 2x is equal to matrix A, right? So we actually cannot multiply matrices, or sorry, we cannot divide matrices, interestingly enough. So what we have to do is we have to multiply by what's called the inverse. So let's say then that I have matrix, and that was a bad example last there, so A times X is equal to B, where A and B are known matrices. So they're both known. And we want to solve what X is. Now, usually what we would do is we'd say that X is equal to B divided by A in terms of simple algebraic terms. So we divide out the A here, we divide out the A over there. But really, because of the way that matrices work, and you notice that the multiplication is a little bit different, so of course the division is going to be a little bit different. So when we're going to solve for X, it's actually going to be B times A to the negative 1. This is the inverse matrix for A. So really what we need to do is we need to multiply some matrix by the inverse in order for us to solve what X is. Now, the more practice you get with the next concept that's down the line, you will understand this a little bit more. But in order for you to take the inverse matrix, this doesn't necessarily need to be understood just quite yet. So I'll erase some of these things, and we'll talk about what the actual inverse matrix will be. So let's say I have a matrix of A, and it's equal to, again, I'll use the skeleton of A, B, C, and D. Well, the inverse of a, so we always denote the inverse of a by a to the negative 1, is going to be equal to 1 over the determinant of a. So that's where we had our determinant conversation from before. Remember, the determinant is just AD minus BC. 1 over the determinant of a, and we have to do some funky things with our numbers inside of our 2 by 2 matrix. So we actually have to switch the positions of D and A. So whatever number was associated with A now comes from up top left to bottom right. We change the sign on B and C. So now they're both negative. So what this does here is that actually creates an inverse of the original matrix. Now, of course, you're probably wondering, can you give me an example? This all kind of looks a little bit weird. So let's say that then A is equal to, let's go with some numbers that will hopefully work out. So 6, 2, 3, and 4. And I want to find the inverse. So usually step 1 would be to find the determinants, right? Because the determinant shows up here before we multiply in. So the determinant of A is going to equal A times D, which is going to be 6 times 4, and I'm going to subtract B times C, so 2 times 3. So that's going to be subtracted by 2 times 3, and so that should give me 24 minus 6. So 24 minus 6, and that gives me a total answer of 18. Right, so this is 18. So now I know that when I'm dealing with my inverse matrix, I'm going to put my determinant as 18. So here a to the negative 1 is equal to 1 over 18. Right? That's where my determinant comes from. And now I will rearrange these things. So 6 has to come down below and 4 has to come back up top. So we're just switching the positions of 6 and 4. We're going to change the sign on 2 and 3. So negative 2 and negative 3. And then you're done. Right? So this is the completed inverse matrix. Now, depending on how nice this number is and depending on how nice your teachers are, you may or may not have to actually put that number in on each of these, right? So if I were to continue with this, and if they were to say completely simplify, so this would be the completely simplified terms, where we could say that this is going to be 4 over 18, right? Because remember, anything in front is a scalar that gets multiplied in. So we're going to say 4 over 18, negative 2 over 18, negative 3 over 18, and then finally 6 over 18. Now, of course, these all can be simplified down to its lowest terms. I'm running out of space, time, and breath, so you can do that on your own. This is how you find an inverse matrix. There's lots of practice in your textbook. Follow along with your checkpoints and ask your teacher if you need a hand.